Here we're going to look at topic 75, example 2, where we choose a solution method. We're asked to solve the equation 6x squared minus 7x minus 20 equals 0 using two different methods, and then we're asked which do you prefer and why. Okay, so definitely this textbook really cares about our opinion. So let's start with the first one, and I'm going to use the quadratic formula as my first option. Right, because this section is the quadratic formula section. So in the quadratic formula, right, we have x is equal to negative b plus or minus b squared minus 4ac over 2a. And we need to figure out what a, b, and c are. So I'll label them up here. A would be equal to 6, b is equal to negative 7, and c is equal to negative 20. So let's label those. So a equals 6, b equals negative 7, and c equals negative 20. Okay, so let's plug our numbers in and simplify our terms. So x is equal to negative 7 plus or minus negative 7 squared minus 4 times 6 times negative 20. And that will all be over 2 times a, which is 6. Okay, so we got a lot of numbers here. We need to simplify some of this. So let me just highlight here. B was in orange, and C was in red. Okay. All right, so continuing on. X is equal to 7 plus or minus. We'd have 49, negative 4, 6, and negative 20, so that's going to be a positive because we have two negatives. And then we need to multiply these, and we get 480. Okay. So continuing, oh, let's not forget the 2 times 6, that would be 12. So x is equal to 7 plus or minus 49 plus 480 would be 529. We need to check to see if 529 is a perfect square. So try to take the square root of 529. We can take the square root of that. So 529 is a perfect square. It would be 23 times 23. So the square root is 23. All right, from here, we're looking for the actual solutions. So we're not actually done. This is the step where we would need to split this up. So we would have x equals 7 plus 23 over 12. And we would have 7 minus 23 over 12. So this shouldn't be too bad to simplify. 30 over 12, that would reduce to 5 over 2, or 2.5, but we'll leave it as 5 over 2. And then here, we would have 7 minus 23, should be negative 16 over 12, and that would reduce to negative 4 over 3. Again, you could write the 5 over 2 as 2.5, but probably leave it this way. So these are our two solutions using the quadratic formula. All right, so that was the first method. We'll call this method 1. There's really four main methods you can use. You have the quadratic formula, you have factoring, you have graphing, and you have completing the square. Completing the square for this example would probably be a nightmare. You're going to be dealing with a lot of fractions, and so I'm not going to try completing the square. I already know this problem is factorable because I'm looking at the textbook, so I know that. But looking at it, I'm going to choose method 2 as factoring. Now, I wouldn't know this is factorable just by looking at it. So you would have to kind of do a trial and error here, right? You'd have to look at this and maybe try and factor it. And that's why you'll find that the quadratic formula is sometimes a bit more useful because you know the quadratic formula is always going to work. Factoring only works if the problem is factorable. And if I had something like x squared plus, let's say 8x plus 15, That's pretty easy to check for factoring. All right, and that's would be x plus 3, x plus 5, and that would be really easy. The problem that they give us here is not that simple. So the factoring method, although it will work in this problem, probably not going to be my choice. But let's go for it anyway. All right, so we're looking at factoring. We have 6x squared minus 7x minus 20. Now we're going to use the AC method here. So we're going to do A times C, which means we're going to do 6 times negative 20, and we're looking for factors of negative 120 that have a sum of negative 7, right, our B term. Right, so I already decided I don't like this problem. I definitely don't want to factor this. 120 has a lot of factors, so I would have to make a long list. I'm going to write them all down anyway, and we'll just go from there. Apparently I'm a glutton for punishment. All right, so 3 and negative 40, 4 and negative 30, 5 and negative 24, so 6 and negative 20. So that doesn't work. 120 divided by 7, it doesn't work, but let's just make sure. 120 divided by 8 is going to be 15, and we found what we're looking for. So 8 plus negative 15 is negative 7. That's the one that works. So those are our factors. So I would do 6x squared plus 8x minus 15x minus 20 is equal to 0. So again, we've already found that we didn't even know well, we knew because I said it and the textbook told me that this was going to work, but we didn't even know that that was going to work to start. So that's why this problem really wouldn't recommend factoring, but we'll go for it anyway, like I said. So now we're going to take our first two terms, we're going to factor by grouping. So these two would be, let's see, they have 2x in common, so I'd be left with 3x plus 4. So if I factor that, and then the second group, these two will go here. And if I factor them, I need to change the signs, so I'm going to take out a negative 5. So I'd be left with 3x plus 4. Remember when you're factoring by grouping, let's use a color I haven't highlighted yet. These two need to match up. If they don't match up, then it's not working. So we're going to rewrite that as 3x plus 4 and 2x minus 5. And now I can create my two equations using the zero product property and solve for x. So x is equal to negative 4 over 3, which is what I got using the quadratic formula. And my second solution, I got x is equal to 5/2, which I also got using the quadratic formula. So for this specific problem, method 1, quadratic formula, probably way better. Method 2, factoring does work, but we did not know that going in. If this was just kind of a problem that we're starting with a blank slate, we could wind up trying this whole AC method to list a whole bunch of pairs of factors to realize that it doesn't even work. So if you're not sure if it's factorable, go to the quadratic formula right away. Quadratic formula, although a little bit tedious at times, right, because there is a lot of substitution, could look a little bit messy, it'll always work. The quadratic formula will work for every single quadratic equation, so I highly recommend sticking to the quadratic formula if you realize that maybe a problem is not factorable. And I am done talking and explaining that. Which method do I prefer? Quadratic formula. I'm not going to explain why. I already did.